Acids and bases 5. Acid deposition. The essential idea. Increased industrialization has led to greater production of nitrogen and sulfur oxides, leading to acid rain, which is damaging our environment. These problems can be reduced through collaboration with national and intergovernmental organisations. Nature of science. Risks and problems. Oxides of metals and non-metals can be characterised by their acid-base properties. Acid deposition is a topic that can be discussed from different perspectives. Chemistry allows us to understand and to reduce the environmental impact of human activities. Theory of knowledge. All rain is acidic, but not all rain is acid rain. Scientific terms have a precise definition. This can make you think, does scientific vocabulary simply communicate our knowledge in a neutral way, or can it have value-laden terminology? Pollutants, some terminology. A pollutant, oh that's quite small. A pollutant is a substance that has a harmful effect on the environment and is present at concentrations greater than its natural levels as a result of human activity. A primary pollutant is a pollutant that is directly released into the atmosphere or other part of the environment. Some examples include carbon monoxide, sulfur dioxide and nitrogen monoxide. Secondary pollutants. A secondary pollutant is a pollutant that forms when a primary pollutant undergoes a chemical change in the atmosphere. And these would include sulfur trioxide, nitrogen dioxide, and acid depositions from nitric acid and sulfuric acid. Pollutants may be categorized according to their source. Natural sources of pollutants include normal activities in an ecosystem. Examples would include decomposition, volcanic activity, electrical storms, biological activity, and geological processes. Anthropogenic sources of pollutants are the result of human activities. Examples include combustion of fossil fuels in power plants, factories, vehicles, engines, use of synthetic organic materials like solvents and paints. Okay, let's look at sulfur oxides. Sulfur oxides, SO2 and SO3, we've got the dioxide and the trioxide. We do have natural sources, but these have a very limited contribution under normal circumstances. Sulfur dioxide may be produced through the oxidation of hydrogen sulfide gas produced by volcanoes and decomposing organic matter. Here you can see the reaction there with the hydrogen sulfide reacting with oxygen to give sulfur dioxide and water. Anthropogenic sources. Most of the pollutant sulfur oxides in the air come from human sources, mainly the burning of sulfur-containing fuels such as coal. Smelting industries which purify metals from mined ores and sulfuric acid manufacturing plants also produce sulfur oxides. The sulfur oxides, SOx, are a good example of the difference between primary and secondary air pollutants. Sulfur dioxide is a primary air pollutant. Sulfur impurities in low-grade coal react with oxygen during combustion reactions, usually in coal-fired power plants, and this would include the one on Llama Island, which is where I live. Sulfur dioxide is released directly into the atmosphere. So sulfur as a solid is reacting with oxygen gas to give sulfur dioxide. Sulfur trioxide, on the other hand, is a secondary air pollutant. Sulfur dioxide reacts with oxygen in the atmosphere to produce sulfur trioxide. To reduce the amount of sulfur oxides produced, let's look at some methods of reduction. First, pre-combustion removal of sulfur from fuels. Sulfur is present in low-grade coal as metal sulfides. These can be physically removed by the process of coal washing. You crush the coal into a powder, wash it with water, and then the clean coal will rise in the solution and dense metal sulfides sink to the bottom. B. Use a higher grade form of coal that is naturally low in sulfur, such as anthracite, which is an example of a form of coal with a low sulfur content. Some pros. This does reduce sulfur in coal pre-combustion, but there are cons. A. It's difficult to remove all sulfur using the coal washing method, and anthracite is scarce and expensive. Post-combustion removal of sulfur dioxide from exhaust. Sulfur dioxide can be reduced from the exhaust fumes produced by a coal-burning power plant or factory before being released to the environment. So, if you've got some coal, here, and you burn it, some sulfur dioxide is released. You can then react the sulfur dioxide with alkaline compounds such as calcium carbonate, magnesium hydroxide, and calcium oxide. The sulfur dioxide reacts with these to form solid compounds which are removed as sludge and can be reused for other purposes. And the exhaust gas then has much less sodium sulfur dioxide content. Two methods can be used: wet alkaline scrubbers or fluidized limestone beds. Let's look at the wet alkaline scrubbers first. So first of all, we've got our coal and it's being burnt and sulfur dioxide is being released. It goes into the chimney and there's carbon dioxide, sulfur dioxide and water or steam present in that mix. Oops, I want it. Next, wet alkaline mixture with calcium carbonate, calcium oxide or magnesium hydroxide in water is sprayed onto the gases. Then we get these reactions. The calcium carbonate reacts with sulfur dioxide to form calcium sulfite and carbon dioxide. The oxide forms calcium sulfite and magnesium hydroxide would form magnesium sulfite. So the sulfur dioxide is being removed in the scrubber reactions. All of these you can see are solids and these form the sludge at the bottom. These, the solid calcium sulfite and magnesium sulfite that form as a sludge can be used in other industrial processes such as building materials. And the carbon dioxide gas and steam will then go out the top of the chimney. And there should be very little to or no sulfur dioxide. It's very effective, this technique, but it is expensive. The equipment is expensive initially and you get a build-up of calcium sulfite on the scrubbers. Okay, fluidized limestone beds. Coal mixed with sulfur impurities is mixed with powdered calcium carbonate. So the coal is mixed in with calcium carbonate to start with. Then heat and in the presence of oxygen is added and you get coal combustion producing carbon dioxide, water vapour and sulfur dioxide. The heat decomposes the calcium carbonate to form carbon dioxide and calcium oxide. Then the sulfur dioxide reacts with the decomposition products of calcium carbonate. You get calcium oxide reacting with sulfur dioxide to form calcium sulfite. And you also get calcium oxide reacting with sulfur dioxide and oxygen to give us calcium sulfate. The solid sulfite and sulfate are removed and reused. Then the exhaust gas is free of sulfur dioxide and composed mainly of carbon dioxide and water vapour. It's very effective, but again it is expensive. Let's look at nitrogen oxides next. So we've got nitrogen monoxide and nitrogen dioxide. Natural sources, again a very limited amount of nitrogen oxides come from this source. Nitrogen gas is very stable. It has that triple bond and doesn't normally react with oxygen to form nitrogen oxides. However, the lightning in electrical storms has enough energy to make the two gases react. Also, certain soil bacteria have enzymes that oxidize the nitrogen gas. You see here, nitrogen gas, oxygen gas forming nitrogen monoxide. The anthropogenic sources contribute a lot more. The combustion of various fuels produces enough energy to react nitrogen and oxygen gases. Combustion of fuels in internal combustion engines in vehicles is the major contributor to nitrogen oxides in the atmosphere. Temperatures in internal combustion engines may reach 1,500 degrees Celsius, increasing the fraction of reactants with sufficient kinetic energy to overcome the activation energy. Other industrial processes also contribute to the production of nitrogen oxides. So, nitrogen monoxide is a primary air pollutant. It's produced when energy is released by combustion processes, enabling the reaction between nitrogen and oxygen gases. Nitrogen dioxide is a secondary air pollutant. The nitrogen monoxide reacts with oxygen in the atmosphere to produce nitrogen dioxide, a reddish-brown gas, and is a component of photochemical smog. The formation of acid deposition. Formation of acid deposition. A preview. We've got industry, transport, domestic sources and electricity generation kicking out nitrogen oxides and sulfur oxides into the atmosphere. These undergo something called photooxidation, and you get acid pollutants, and the nitrogen dioxide and sulfur dioxide will form nitric acid and sulfuric acid. These acids can then land directly on the surface of things, or can mix with rain or snow to fall in a liquid form. Acid deposition is the process by which acidic gases and precipitation leave the atmosphere. Dry deposition again is when particulates and gases are absorbed by surfaces directly, could be plants, materials and lakes. Wet deposition is in precipitation. I didn't mention fog before. So we get precipitation of acidic compounds from the atmosphere. Rain is naturally acidic. The pH of clean rain is 5.6. And all living things produce carbon dioxide. And you'll be doing it right now as you breathe out. I'm going to blow some into the microphone. Carbon dioxide reacts with water vapour in the atmosphere to produce carbonic acid. Carbonic acid is a weak acid and it forms solutions with a minimum pH of 5.6. This type of precipitation is not what we call acid rain. Carbon dioxide is not considered to be a cause of acid rain. Acid rain is caused by environmental pollutants. The pH of acid rain is less than 5.6, and even though the pH difference between clean rain and acid rain doesn't seem like much, it is actually very significant when you think about the concentration of hydrogen ions rather than just the number of pH. The hydrogen ion concentration is what determines the acidity of solution and its effects. So, regular rain will have 2.5 times 10 to the minus 6 concentration of hydrogen ions. If you just drop to 5, so a 0.6 difference in pH equates to, it goes down to 1.0 times 10 to the minus 5, which is 4 times more acidic. And if you go down to 4, which again doesn't seem like a big leap if you look at the pH scale, but remember it's logarithmic, it's actually 40 times more acidic. Okay, formation of acid deposition. Let's look at sulfur oxides and nitrogen oxide emissions and acid depositions. Sulfur oxides. Sulfur dioxide is a primary pollutant formed mainly by coal burning. Sulfur impurities in coal react with oxygen gas to form sulfur dioxide. So the sulfur dioxide reacts with water in the air to form sulfurous acid. This is a weak acid. Sulfur trioxide, the secondary pollutant formed when sulfur dioxide is oxidized in the air, will then also react with water in the air. And this produces a different acid, sulfuric acid. And this acid is a strong acid. Nitrogen oxides. Nitrogen monoxide, the primary pollutant formed mainly in the internal combustion engines of vehicles, where high temperatures promote the reaction between nitrogen and oxygen gases in air, can be seen here. Nitrogen dioxide is the secondary pollutant formed from that nitrogen oxide when it's oxidized in air. The nitrogen dioxide reacts with water in the air to produce a mixture of nitrous and nitric acids. Nitrogen dioxide also reacts with oxygen and water to form nitric acid, a strong acid. The effects of acid deposition. Effects on buildings and materials. Stone buildings and statues usually made of marble or limestone, which contains calcium carbonate. Sulfur dioxide or sulfuric acid react with carbonates to form calcium sulfate. So you've got calcium carbonate, which your building could be made of, reacting with sulfur dioxide and oxygen to give calcium sulfate, which will dissolve in water. This would be considered dry deposition. Wet deposition here, you've got calcium carbonate reacting with aqueous sulfuric acid, which may come with rain, giving the soluble calcium sulfate, carbon dioxide and water. Calcium sulfate is more soluble than calcium carbonate, and it washes away from the limestone or marble, eroding the structure. The corrosion of iron and other metals is also increased by acid rain. This causes major damage to bridges, railroad tracks and vehicles. The dry deposition reaction would be iron reacting with sulfur dioxide and oxygen to give iron sulfate. The two wet deposition reactions would be iron with sulfuric acid, giving iron sulfate and hydrogen gas. And here's another example. Aluminium oxide with nitric acid, giving the aluminium nitrate. Effects on aquatic life. And this is just for your information only. The low pH value affects the hatching of eggs, as well as a variety of functions in adult fish. Acidic conditions also cause the leaching of aluminium ions in aluminium compounds in rocks. Aluminium ions then enter the water supply. The aluminium ions disrupt the function of gills in fish. Sensitive species like salmon and minnows can't survive in pH values below 6. Trout and perch die at pH values below 5. And at pH levels below 4, a lake is essentially considered dead. Nitrogen compounds in acid rain may cause eutrophication, overnourishment of ponds and lakes. This is when high levels of nutrients in the water stimulate blooms of algae. When the algae die, oxygen in the water is used for decomposition. This removes the oxygen needed by other aquatic organisms for survival. Effects on plant life. Acid rain can change the chemistry of soil. Important plant nutrients like potassium, magnesium and calcium ions are leached out by acid rain, therefore reducing plant growth. Low magnesium ion levels also disrupt chlorophyll formation, causing leaves to become yellow and reducing photosynthesis. And acid rain also increases the levels of aluminium ions in soil by leaching aluminium out of rocks and into the soil. High aluminium levels damage the roots of plants and prevents the absorption of water and nutrients from soil. Breathing air with fine droplets of acid and acidic gases irritates the mucous membranes in the nose and throat, and also damages lung tissue. The risk of conditions like asthma, bronchitis and emphysema is increased. Eye irritation is also associated with acid compounds in the air. Levels of toxic metal ions in drinking water may also arise due to the leaching effects of acid rain. Lead and copper levels may rise as acidic water travels through water pipes. Aluminium levels may also arise as previously described. High levels of aluminium is thought to be associated with Alzheimer's disease, a form of senile dementia. And that's the end of that presentation. Splendid.